Chapter 2 Vectors. A scalar. Many familiar physical quantities can be specified completely by giving a single number and the appropriate unit. For example, the distance between two posts is 100 meters. A physical quantity that can be specified completely in this manner is called a scalar quantity. A scalar is a synonym of number. Time, mass, distance, length, volume, temperature, and energy are examples of scalar quantities. Scalar quantities that have the same physical units can be added or subtracted according to the usual rules of algebra for numbers. Vectors. Physical quantities specified completely by giving a number of units, magnitude, and a direction are called vector quantities. Examples of vector quantities include displacement, velocity, position, force, and torque. In the language of mathematics, physical vector quantities are represented by mathematical objects called vectors. We can add or subtract two vectors, and we can multiply a vector by a scalar or by another vector, but we cannot divide by a vector. The operation of division by a vector is not defined. Displacement. Displacement is a general term used to describe a change in position, such as during a trip from the tent to the fishing hole. Displacement is an example of a vector quantity. The length of the arrow represents the magnitude d of vector d with the arrow notation on top of the capital letter D. Since the magnitude of a vector is its length, which is a positive number, the magnitude is also indicated by placing the absolute value notation around the symbol that denotes the vector. Algebra of vectors in one dimension. Parallel vectors. Two vectors that have identical directions. They are parallel to each other. Antiparallel vectors, where the minus sign indicates the antiparallel direction. They can either be in the same direction or the opposite direction. Equal vectors. Two or more vectors are said to be equal when their magnitude is equal and also their direction is the same. Orthogonal vectors. Two vectors with directions perpendicular to each other. This slide shows parallel, antiparallel, equal, and orthogonal vectors. This slide shows an example of equal vectors. Vector AB equals vector CD. They have the same length and they are in the same direction. And the other one, negative vectors, vector AB equals negative vector BA. They have the same length, but they are in the opposite direction. Algebra of vectors in two dimensions. For a two-dimensional vector, the magnitude is equal to the length of the hypotenuse of a triangle, in which the sides are the x and y components. Therefore, if you know the two components of the vector and want to find the magnitude, you can use the Pythagorean theorem. Vector addition. To add vectors, we can use the head-to-tail method. 1. Place the tail of one vector at the tip of the other vector. 2. Draw an arrow from the tail of the first vector to the tip of the second vector. This new vector is the sum of the first two vectors. Vector subtraction. The subtraction of a vector is the same as adding the vector in the opposite direction. Finding perpendicular vector components. A vector can be represented as the sum of two perpendicular vector components. To find the horizontal and vertical components, we draw a right triangle with the vector as the hypotenuse D. One way to choose the sides of the triangle is the following. First, the horizontal component D sub x starts at the tail of D and is parallel to the horizontal axis. The head of the horizontal component has the same horizontal position as D. Second, the vertical component d sub y starts at the head of d sub x and ends at the head of the original vector. D sub y is parallel to the vertical axis. Vectors can be added together and multiplied by scalars. Vector addition is associative and commutative, and vector multiplication by sum of scalars is distributive. Also, a scalar multiplication by sum of vectors is distributive. The scalar product of two vectors, or the dot product. The dot product of two vectors, also called the scalar product, is a number, a scalar quantity, obtained by performing a specific operation on the vector components. The dot product has meaning only for pairs of vectors with the same dimensions. Cross product. Cross product is also called a vector product. Cross product is a form of vector multiplication performed between two vectors of different nature or kinds. When two vectors are multiplied with each other and the product is also a vector quantity, then the resultant vector is called the cross product of two vectors, or the vector product. The resultant vector is perpendicular to the plane containing the two given vectors. Torque. What is torque? Torque is a measure of the force that can cause an object to rotate about an axis. Just as a force causes an object to accelerate in linear kinematics, torque causes an object to acquire angular acceleration. Torque is a vector quantity. The direction of the torque vector depends on the direction of the force on axis. The radial vector r represents the distance r from the knot to the point where force vector F is attached. Work. The work done on a system by a constant force is the product of the component of the force in the direction of motion times the distance through which the force acts. For one-way motion in one dimension, this is expressed in equation form as W equals F times D cosine theta, where W is work, F is the magnitude of the force on the system, D is the magnitude of the displacement of the system, and theta is the angle between the force vector F and the displacement vector D.